Hey Algebros! This is our last hurrah in the unit on powers and roots, and that's by finding the distance between 2 points found on the coordinate grid. Previously, last time we were given 2 points, we were finding the slope between them. So when we're given 2 points A, let's call it XA, YA as its coordinates, and another one B, XB, YB. Last time we saw this kind of configuration, we were finding slopes. This time, we're not going to do that. Now, I'm going to write that we can find the distance between these 2 points with a formula That formula is as follows. I usually write it as d representing our distance, and it equals a gigantic square root of the subtraction of the x coordinates. And you square that, plus the subtraction of the y coordinates, also square that. One thing you may be surprised is that this is based off of the Pythagorean theorem So now we're going to see the graph in this case. What this amounts to being is as follows. I've drawn out a set of points over here. We're looking for the distance between A and B. So we want the distance between A and B. All right? I'm going to draw out that line right here. Very roughly, not to scale, but I mean, you know, it is what it is. I want that shortest distance between those 2 points. You'll also notice that I've also plotted a point C over here. We'll get to that in a moment. The coordinates for A are -4, -3, and for B, it's 4, 3. Okay? The beauty of right here, and how that formula that we've seen previously falls into things, is if you try to create a right triangle using the point C as the location of the right angle. Okay? So what you see here with these dotted lines, aren't these just legs? Yeah, they're basically just the legs here. Now, what this amounts to now is, if I know the lengths of the legs, I can find the hypotenuse distance, which this is what we want right here. This hypotenuse length is that distance we're looking for. That is hype indeed. So what this means, what does this amount to, is that if I can find out what this distance is, and what this distance is for these 2 legs, we can find the hypotenuse with the Pythagorean theorem. Now, C is chosen very wisely here. C is chosen in such a way that we've moved completely horizontally this way and completely vertically this way. So we retain the y-coordinate of A and the x-coordinate of B. So this point is 4, -3. And if you look very closely, these legs are nothing more than the subtraction of the x's and the subtraction of the y's. For example, the one from A to C, this one over here, isn't it just the x-coordinate of A minus the x-coordinate of C, which is just the x-coordinate of B? And this one over here, isn't it the y-coordinate of B minus the y-coordinate of C, which is just the y-coordinate of A? I'm writing it backwards, but here's the thing. It won't matter at the end of the day, because with the Pythagorean theorem, what do I have to do? I have to square them both. Once we square them both, we'll get a number that is going to be positive no matter what. And then you add them together. After that, and after, you square root. I know this looks a little bit messy, but if you want to copy this down as a coordinate plane, this is an extremely helpful diagram over here that will help you out when it comes to understanding the Pythagorean theorem. So, when you see the graph, so let's find that distance. Properly. Again, the A coordinate here was -4, -3. The B coordinate was 4, 3. let's apply it completely directly as it's given. This formula is a bit long, but I'm sure you can commit it to memory with enough practice. So here, it's going to be xa minus xb squared plus ya minus yb also squared. Again, doesn't matter which direction you're going when it comes to the x's and the xa, xb, ya, yb. So the ya, yb direction doesn't matter, again, as long as you're consistent. So the a, b direction doesn't matter, as long as you're consistent. Again, just like when we're finding slopes. See so much parallel between math? It's absolutely beautiful. Another thing to ask real quick, why the square root? Well, if we're thinking of this as the Pythagorean theorem, this here is a squared. This is b squared, but d doesn't have a square on it, so it's just c. The square root is for us accounting for that positive square root. Again, we're dealing with only positive values here, so when we take the root, eventually, we're only dealing with the positive outcome. So here, replacing values exactly as they are, the x's will be negative 4 minus 4, all squared, plus, for the y's, negative 3 minus 3, no comma here, sorry, also squared, equals, now, negative 4 minus 4 is negative 8, all squared, plus negative 3 minus 3, negative 6, also squared. Squared numbers, negative squared numbers, that ends up positive. Because remember, it's negative 8 times negative 8, which is positive 64. Plus, same thing for the 6. Negative 6 times negative 6 is 36. Positive. We'll be left with the addition of that, which is 100. And we know what the square root of 100 is. That's 10. So it's 10, don't forget this, 10 units. We were not given a specific measurement like inches or centimeters or anything, so we're just going to mark it as units. At the end of the day, all this is the application of a single formula, which is what I want you to try up next. All right? So find the distance between 2 points that I will give you right here. Point A is going to be 12, 3, and point B is going to be 0, 7. No calculators. And write the answer as a simplified radical. There we go. The unit has concluded. We're going to do a lot of practice on this and the Pythagorean theorem coming up soon, so no worries if it's not quite there yet. I'll see you in the final unit in these videos, and that's quadratics. Well, at least I think it's going to be the final unit. If we have more time, we'll have time for something even more fun at the very end. But until then, peace.